Okay, example 6.2. Write a function named Cumulative Sum that uses a loop to compute the cumulative sum of the input vector. As we've seen before, when learning a new skill, writing our own functions to perform the same operations as built-in functions is excellent practice, as we can quickly check if we get the right answer. So what this last paragraph is telling us is MATLAB has a built-in function called CumSum, which does exactly the same thing. So we'll be able to use that to check to make sure our code is working correctly. And so by cumulative sum here, we're going to have an input vector of x, and so we're going to have some final vector called y. Y will contain all of the partial sums of x. So the first element of y will contain the first element of x. Second element of y will contain the sum of the first and second elements of x. Third element of y will contain the sum of first, second, and third elements of x, and so on and so forth. So this will be a fun example problem because we can solve it in a number of ways. So let's jump over to MATLAB and let's do it. Okay, so here I am over in MATLAB. So we're going to create a function. So I'm going to start with the new script button on the Home tab to bring up an editor window. So I'll start with my documentation. So this will be a function to compute the cumulative sum of an input vector. We'll call it, say, x. Okay. The resulting vector will contain all of the partial sums of x. Okay. Our signature starts with the keyword function. Okay. Even though the output here is going to be a vector, we'll still use res as my output variable. Function name, I'm told to call it cumulative sum, and I'll have an input of that vector x. And I'll copy and paste my signature up here. Okay, good. All right. So let's do it. If I use a vector y, say to store all of my partial sums, we can start by initializing it. One, so that since we'll know the final size, the size is going to be the same as x, we can presize it. But then two, just like when we were computing sums before with scalars and we had an accumulator variable, let's initialize y so that all the elements of y are 0. So let's initialize our partial sum vector. So y will be equal to zeros, one row, length of x. Okay, cool. All right, now what? Well, if I try and brainstorm, there's a number of ways to solve this one. But the first way I might think of it is, as we just talked through it, the first element of y is going to be equal to the first element of x. Then the second element of y will be the sum of elements 1 and 2 of x. Or put differently, y of 2 will be equal to y of 1 plus x of 2. Okay? Or more generally then, y of I will be equal to y of I minus 1 plus x of I. Okay? And I can build it up in that way. Okay? And so if we start then, okay, the first elements of x and y are the same because y1 will just be the sum of x from 1 to 1, which is just x1. Okay. Then, so we'll begin our for loop to go from 2 to length x. And so in general, the ith element of y will be equal to the I minus 1 element plus the xi element. So again, the general idea is y1 will will just be equal to x1. Then y2 will be the sum of x from 1 to 2. So it'll be x1 plus x2. Well, x1 is just y1. So that's equal to y1 plus x2. If I go to the next step, y3 is equal to the sum of x1 plus x2 plus x3. That's the same as y2, where y2 contains the sum of x1 and x2 plus x3. So in general then, y of I is equal to y of I minus 1 plus xi. So in terms of that first step, it had to be taken out of the loop, where it's just y1 is equal to x1. And then it's important that in this for loop, we start with the lower bound of 2, so that when I try and reference of I minus 1 in that first iteration, that's 2 minus 1, it's y1. If I had started with a lower bound of 1, this would give me an out of bounds error, because you're not allowed to have an integer, an index of 0. Right? Remember, it has to be a positive integer index. Okay, so that should be that. And then before we exit, we want to store to res what we want to return, which in this case is y. Okay. Oh, I need to save it, and so by default it'll save with cumulative sum. Alright, so let's test it out. Okay, so the input vector doesn't need to be called x, it could be called anything that'll assign to x. So let's say v is equal to 1 to 8. Okay, so if I were to run, we'll call it S1, the solution with using our built-in code is cumulative sum of v. I get an error message. It's telling me I misspelled length. And I did. So fix it up, save it. Let's try again. So S1's cumulative sum of v, we get this. And if I compare that to the built-in cum sum, we get exactly the same answer. Excellent. Okay, so our built-in function is working correctly. That's great. Okay, let's see how we might tweak this. Okay, so if you want, you can stop my video here, but let's save a copy and let's just look at a couple of different ways we could solve the same problem. So if I were to call this cumulative sum 2, okay, so it just suggesting I update the name. So I'll update the name of my signature here. Okay. Rather than pulling it out, I could include it within my for loop. Okay. But what I would have to do is I could add a logical check where if I is equivalent to 1, and this is my first iteration, I just have y of 1 is equal to x1. Else means I is greater than 1, and I could have that. And then I just need to end my logical block. Okay, so I could add a logical block like this, where for the first iteration, when I is equivalent to 1, y1 is just equal to x1. Then for all other iterations, we have the formula we just used. So if I store to say S3, the result of cumulative sum 2, hey, same answer. Great. Okay. Having written this, it gives me another idea. Okay, let me save this as cumulative sum 3. Okay. Update the name. Okay. So what I could do is if I delete this, now that I have a handle for how it works, delete that, shift down, and I'm going to start with iteration 2 just as before. I could just initialize y by just copying essentially x, by assigning to y the values of x. So y will become a vector of the same size as x that contains all of its elements. So then, the first element of y is equal to the first element of x, so I don't even need to worry about an assignment for the first element, and can just start with 2. So if I run cumulative sum 3, I got it. Okay, cool. Okay, did you want a fourth iteration? So the other way we could do it is in the text, actually take advantage of using nested for loops. Okay, so in the interest of doing it, we can. Say this is cumulative sum 4. Okay, update the name accordingly. So I'm going to go back and I'm going to initialize y, just like we did before. 0 is 1 comma, the length of x. Okay. And so what I'm going to do is I'm going to loop over x just as before. Okay. And so I'm going to loop over x, and so when I try and calculate the corresponding element of y, right, yi will be the sum of all of the elements of x from 1 all the way up to I. Okay, so yi will be the sum of all of the elements of x from 1 all the way up to I. So if I wanted to do that, I could add another for loop for j equals 1 to I. So that yi is equal to yi, which is like when we had an accumulator before, plus xj. Okay, so how this would work is y we create, it's the same size as x, all the elements are 0, just like when we had accumulator variables before. And so if I look at this outer for loop, okay, first iteration, so I'm going to go from I equals 1 to length x. So when I look at this outer loop, what I'm thinking of is I'm trying to calculate the ith element of y. Okay, so the ith element of y is going to be the sum of all of the elements of x from 1 up to I. So to sum up the elements of x from 1 up to I, I'm going to create a for loop that loops from 1 up to I. So when I first enter this inner loop, yi will contain a value of 0. I'll add to it x1, loop around. It'll be the current value of yi, which was x1, and I'll add to it x2, and so on and so forth, and till we get everything. And so if I try running cum sum 4, hey, we get exactly the right answer. Excellent. And so by this point, I'm sure you've had enough cumulative sum.